good. Just stressing out over the calculus test we have on Monday. Oh, you're stressing out too? That's funny. You wanna meet up tomorrow? Oh, okay. At the library? How about 5 or 6? I'm leaning more to 6. Alright, so tomorrow at the library at 6. Alright then, I'll see you there, Calvin. Bye.
Are you okay? Are you serious?
911, what's your emergency?
Yes, it's been an accident. It's a hit and run. The driver's hurt and she's bleeding. I don't know what to do.
Sir, where are you right now?
We're in an Ancho vehicle. She's on the Main Street Balboa. It's on the curve.
By any chance, do you know calculus?
Of course I know calculus. I'm in Miss Smith's AP classroom. How's that going to help us here?
I need you to calculate the area on the 2 curves to establish a safety zone for when the medics can arrive.
Yeah, I'll just get here. She's really hurt. She's not breathing. Hello, you okay? I need paper and pencil. Okay. I secured the scene. I told dispatch about the area and they said it's good.
Okay. I'm gonna go ahead and listen to lung sounds. Nikki, she's not breathing. She's not breathing? No. Be very careful, okay? I think she has an open wound here. Well. Go ahead. She has a contusion to her left clavicle. Hey, I see bleeding. Yeah. Need some Perlix too. No, she's also out of bed. She has a contusion to her right arm.
1, 2, 3.
Can you move that backboard in, Nikki? No, stay on her head. Hold her head. Hold her head.
I'm holding her head.
Okay. Let her go. We need to go right now. I know. Let's go. Get her feet. I'll get her head. Does she have a pulse? How's it? Stay where you are. Just stay where you are. Want to strap her in and then want to go. Okay, put the one in her side.
Channel 8 News presents an exclusive interview with Shaige Worth and his theory on calculus.
Okay, so as the responsibility given to me as the first responder was to get the area as between the 2 curves, which is the streets, to provide a safety zone for the EMS to arrive on scene. So I took the liberty of drawing an image. We had a median in between 2 streets, and then we had the actual street where the accident occurred. So we had my partner Esmer laying on the ground right here, and I measured the feet between where we were working, which is about, give or take, 12 feet, so about 3 meters. So these are the 2 curves that we're going to be using for our graph. So the graph illustration, we have 2 curves that I drew out approximately to what I thought was about the curvature of the streets. So we have the top, which represents the median, which is y equals negative x squared over 4 plus 3. Then we have the bottom, which represents the street in which Esmer was laying on, which is y equals negative x squared over 10 plus 1. So again, it was about approximately 3 meters, so we're going to go from 0 to 3, just to make this a bit easier. and we're going to be getting the area between these two curves, calculus. So, the equation we set up, we're going to take the area we're going to take the integral from 0 to 3 of top minus bottom. So, we're going to have top, which is the x squared over 4 plus 3 negative, minus the negative x squared over 10 plus 1. And so we're going to distribute this negative to simplify this entire equation so we can get the integral easier. So we're going to have negative x squared over 4 plus x squared over 10 equals, and I did the math and it all ended up summing up to negative 3x squared over 20. And then when we distribute, we're going to get 3 minus 1, which equals 2. Thus, the entire simplification is going to be, again, the integral from 0 to 3 of 3 over 20 x squared minus 2 dx. So from here, we're going to take the integral, the antiderivative of the equation above. So that would be x to the third over 20 minus 2x from 0 to 3 once again. And then we're just going to plug in the x values. So we're going to plug in the 3 first, which is the top, and we plug in the 0, which is the bottom, and we're going to subtract them. And since this entire thing is in the positive area, there is no need to take the absolute value, since the entire value will be absolutely positive. So the area ended up being 93 over 20 meters, which is approximately 4.65 meters. And that's it.
3. 1, 2, 3. Oh my gosh, Sarah, you just saved that young girl's life. What is your name? Like, tell me your secrets. You know what? Hold up. Let's take a selfie right now. You're such a hero. Oh my gosh.
I know. It's Miss Smith. You know they tell you math never comes in handy? Oh, you have no idea, girl. Trust me. Miss Smith, calculus saves lives. See right there? Let's go check up on her right now.
Okay.
Saves lives. How's she doing?
She'll live.
Calculus.
I couldn't. I just saw the light and I couldn't.